Okay, so if I run this, okay, you should get something printed out in your console. Okay, and I'll just save this into a new object. So I'll call this surveys white. Okay, run this. And if I view this, surveys white, you'll see that now we have an expanded data frame, okay, with each of the with new columns representing each genus from the original data frame. Okay, so this is how you can make a kind of long data frame, because if you look back to the original data frame, it kind of have more rows. It has 196 rows. Okay, but if you look at the wider data frame that we have just made, it has less rows. Okay, so it's kind of became wider and shorter. Okay, yeah. But usually if you are looking at making figures in ggplot, ggplot usually it prefers a long kind of format, which is something that looks like this. Okay. So in order to run, before we're running ggplot in the next section, I just want to show you how you could convert from a wide format back to a long format. Okay, so it takes it uses a similar function, okay, but a different name. So we're trying to convert from the wide data, wide to long data format. Okay, so I'll just copy. Let me just see. Okay, that one. I'll just print this out. Okay, so we have our wide data framed. Okay, and we want to make this, or we want to convert this back into the long format. Okay, so how do you do this? So this time we use a slightly different function, okay, which is quite self-explanatory. Okay, so firstly you have pivot wider. Currently you have pivot longer. Okay, so it's actually provides some options for you, yeah, to choose from. So we want to run this one, and for pivot longer, it usually takes in I guess 3 input. Okay, so the first one is the same as, right. So instead of names from, okay, we need names too. Okay, names too is basically the column which you want to pivot your data frame at. Okay, so in this case, you want to combine all of these individual genus columns into a single genus column. Okay, so this is what we should put into. Let's see. Okay, so here I'm using double quotes. I don't quite remember if double quotes are necessary in this case. Anyway,
try and take the double quotes out and start typing and see if it picks it up, because
okay,
that's kind of usually, you know, that autocomplete type of thing. I don't know. That's how I cheat sometimes.
Okay, so I'll just try with quotes and without the quotes the second time. Okay, yeah. And then so we have names to genus, values to, which is the mean weight, okay, which is what we are pivoting back to. And then columns is the plot ID. Okay, so plot ID will kind of remain the same. Okay, and if I run this, okay, and I'll just save it. Okay, I'll just save this into a new object. Okay, so white, make it long. Okay, so now I'm just trying to remove the quotes and see if it runs. Yeah, I'm always confused if we need quotes or not. Okay, so it doesn't. Right, so that means you have to have quotes in this case when you're running pivot longer. So when you're defining each of these different variables. Okay, so if we look at, let's view a new surveys long data frame. Okay, so this is what happens to your previous data frame, okay, when you convert it from the wide format, which is this one, okay, back to the long format. So it kind of squish it into a narrower data frame, but longer this time. So it has more rows, but less columns. Okay. Yeah, so pivot, the pivot functions basically allows you to convert a data frame into either a wider, okay, with more columns, or a longer, okay, with more rows, okay, data frames. So yeah, so I just want to show you very quickly these two functions because it will be useful usually because usually your spreadsheet, okay, will be in a wide format, which means you have a lot of different columns. But when you're making plots like ggplots, you usually have to convert them into a long format, okay, before you can make the plot. Yeah. Okay, so the next or the last part is to show you how you can save a data frame, okay, or save your data and export it into your local folder. Okay, so what I'm going to do is, let's see. Okay, so first I'm going to create a new data frame. Okay, let's just see. And then I'm going to save this new data frame, which we will be using for ggplot next. Okay, so let's see. So we are exporting and saving data in R. Okay, so you have your surveys data. Okay, and what I'm going to do now is I am going to remove some of the any values, okay, the missing values from the data frame, and save this new data frame into a new object. Okay, so what I'm going to do is, so I'm piping my surveys, which is the original data frame, into filter, okay, which is going to remove the rows, okay, with all the missing values. Okay, so first, what I want to do is I want to remove the, let's see, oops, weight, and then let's see, I also want to remove the oops. Okay, and then finally, I want to save this into a new object. Surveys complete. Oops. Right. So if I run this, it will save a new, it'll create a new data frame and save it into this new surveys complete object. Okay, so if I look at this new data frame, it will basically remove all the NA values, all the missing values from each of these columns, each of these three columns. Okay, and then next thing is we want to, let's see. Okay, so because during the ggplot section, we're going to look at how the different species abundance have changed over time. Okay, so we're going to modify slightly, or we're going to create a new data frame actually, okay, from the current one. Okay, which will tell us the most common species in our entire data set. Okay, so to do this, okay, let's create this one. So we'll first run this one. Okay, so what we're running now is we're trying to determine which species are the most common. Okay, and in this case, we just want to select those species that are more than 50, which where the frequency is more than 50. Okay, so just run this. See. Okay, probably send. Yeah, so what this code does is it will count the number of each unique species ID, and then it will filter only those, it will select only those species ID with a number higher than 50. Okay, so if I run this, let me just save this into a new object, species count. Okay, so if I run this, and if I look at species count, okay, so it will show us all the different species ID, okay, with a total number of more than 50. So you don't see any species ID with less than 50 counts. Okay. Right. And then next, we're just going to run one more step here, okay, which is this step. Yeah, I'm just going to save this into the same. Oops. Right. Okay. So I was running this step, and if I look at my new surveys complete data frame, okay, it looks something like this. Okay, so after you have run all the codes that I've just run just now, you should have a new data frame, okay, which is called surveys complete. Okay, and this data frame should have this number of rows and this number of columns. Okay, and this data frame is exactly the one that we will be using to make ggplots in the next section. Okay, so I guess I'll just post this entire chunk of code into Etherpad. So if you miss out at any stage during the previous coding session, you can always go to the Etherpad and run this code. Okay, as long as you have your original surveys data. So I'll just copy this. Let me see. Okay. Just copy this entire thing. Okay, so yeah. So all the codes that we have just run, they are available on the Etherpad now. Okay, so yeah. So right. So I guess we are finished with the with this part of the workshop, which is actually part of the previous lesson. Okay. So next we're moving on to ggplot, okay, which is the most, I guess, the most exciting part in R, because you this is where you kind of get the chance to make your own plots and to actually visualize your data instead of just running codes and looking at tables. Okay, so it actually helps to, yeah, so it actually helps to helps you to, it kind of gives some fun to itself. Yeah. Okay, so let's see. Oh yeah, I missed out something, which is the final part is actually to save your new data frame. Okay, so we have to save this new data frame into your local folder. Okay, so the function or the command is pretty simple. Okay, so firstly we have run the read CSV to read in a data frame from a local folder. Okay, but this time we are going to write your data frame from R into a local folder. Okay, so to write the data frame or to export data framed, we will run the write CSV command. Okay, so what we have to put in is first of all the name of your object of your data frame, which is this one. Just copy this. Okay, and yeah, and then the second thing is the name or the name of the file that you want to save it as. Okay, as well as if you're not saving it in your current working directory, you have to provide the folder which you want to save it into. Okay, or the full path of the file if you're saving it in a different distant folder. Okay, so in this case, we are saving it into our data folder. So if I go back, I have 3 different folders in my current directory, and I'm going to save it into this one, okay, data folder. Okay, let's see. So I'll just name it as surveys complete.csv. Okay, let me check if I already have the, okay. All right. Okay, so if I checked, if I've, before I run this, I just want to check if I have anything in my data folder. So no. So if I run this, it should pop up a new file. Okay, surveys complete.csv file after we've run the R command. Okay, which means that the file, the data frame is successfully has been saved, okay, into our data folder. Okay. Let's see. All right, so up to this point, I guess there should be no questions. So if you have any questions or if you have any difficulties running any of these codes, please let us know in the chat. I'll just also post this onto the Etherpad. Okay. Okay, so now we have everything that we need to run ggplot, okay, to make our figures next. Okay, so yeah, so next let's go into making figures with ggplot. So I often mention ggplot, but actually, in fact, ggplot is the name of the function itself. Okay, what we are using to make plots is actually the ggplot2 package. So ggplot2 is the actual name of the R package itself, and ggplot is the name of the function. So yeah, so for example, if you are making plots with ggplot, you're using the ggplot function, something like this. Okay. Let's see. Yeah, so ggplot2, okay, I mean the package itself is embedded into the tidyverse package, so which we have previously loaded here. Okay, so if you have not loaded the tidyverse package, please do so. Okay, I'll just copy this again here. ggplot2. Right, so first thing before you run ggplot is you need to load the library, okay, the tidyverse library, which has ggplot2 package itself. Okay, so I probably already loaded this, but to just double check, tidyverse. Okay, so tidyverse is loaded, and if I check the ggplot2, you'll see that it was also loaded. Okay, because we have loaded tidyverse. Okay, which includes ggplot2. Okay, so before we go into the codes and the functions that we actually use to make ggplots, I just want to point out a few useful websites. So let me just switch my screen to the, let's see, couldn't find my Chrome screen. I just switch to this one. Okay. Yeah, so I'm switching to this one. Okay, so I'm just going to very quickly go through the tidyverse website. Let's see, I have it here. Yeah, so this is the tidyverse website, like the parent website, which houses all these different packages. You have ggplot2, you have deployer, tidyr. Yeah, I think we did use a few. Yeah, I think the pivot wider and pivot longer functions are both from tidyr. Okay. So yeah, so if you're interested, this is a nice tutorial for tidyverse. I think it is available freely online. That is a free version. Yeah. So I'll just copy and paste this into the Etherpad. Oops, thanks, Angelique, for pasting it in the chat. Yeah, so this is tidyverse package. Okay, and another useful thing is if you go to the help, I think it's the help panel. Okay, if you go to the help panel, there's a couple of cheat sheets for deployer, ggplot2, and a bunch of, I don't know what. Yeah. So if you click on this one, data visualization with ggplot2, okay, what it does is it will download a useful cheat sheet, PDF, okay, onto, yeah, let's see, I think it should be my downloads folder. Okay, which looks something like this. Okay, so in this cheat sheet, you can find not all, but some of the basic ggplot functions. Okay, let me see if I can find something interesting. Yeah, let's see. Yeah, so it has the the basic template to run ggplot. Okay, and how you can save your plot, okay, later after you have created it. And then fasting, we'll look at this one at the very end of this workshop. Yeah, and then the different themes, okay, different themes, which will actually set the background of your plot itself. Okay, yeah, it's kind of a all-in-one cheat sheet for ggplot2. All right. Okay, so now let's go back to our studio. Okay. So yeah, I think I haven't mentioned this, but we probably have a break time at 10. No, sorry, at 9:50. Yeah, so it's so we have a break of 10 minutes at 9:50, which is about 10 plus minutes to go. Okay, so yeah, so now we have loaded our package, okay, tidyverse, which has the ggplot2 itself. what we're going to do next is we're going to load our input data again. So previously we have looked at how you can save this data frame. Okay. Now we're going to reload it, okay, from this folder, okay, into R. So to load a CSV file, we can use the read CSV function. Let me just do this. So I'm going to save, let's see. So I'm going to save it as the same object, okay, as previously. So I'm basically doing what I've done just now. Okay, repeating what I've done. Sweet. Okay. Yep. So if I look at my data frame, surveys complete. Let me just cross off all these. Okay. Yeah, so if I look at my surveys complete data frame, which I've just brought into R, okay, it should look something like this. Okay. And you should get the right number of rows and number of columns. Okay. Okay, so before actually using ggplot, you have to know what is the basic syntax of the ggplot function. So what do you need to have in order to make a minimal plot? Okay, or what are the minimal variables that you need to have in your ggplot function in order to make just a simple plot, a basic one. Okay, so we're looking at a basic template for ggplot. Okay, so when I run ggplot, okay, a very important I would say a concept, okay, the central concept in ggplot is it's kind of like, so let's say if you want to make a scatter plot. Okay, right, a scatter plot. Okay, so a scatter plot is when you have two numerical variables, okay, and you have your x and y axis, and you want to put in all your data points, okay, into a scatter plot, okay, into your figure. Okay, so a central concept in ggplot is that it actually creates your plot in a step-by-step way. Okay, so what this means is that it's kind of similar to when you draw a plot manually. Okay, so when you start drawing a plot, you start by drawing the axis. Okay, so once you have the axis, your x and y axis, you then put in the data points or the dots. Okay, so that is your second layer. Okay, your first layer is your axis, and then your second layer is all your data points. And the next step is probably you want to put in the axis titles, okay, which will make up your third layer. Okay, so maybe you want to label it, label your x-axis, your y-axis, and also give your plot a title. Okay, so this is what exactly ggplot does. Okay, it builds up your plot iteratively. Yeah. It builds out a plot step by step. Okay, I couldn't get the word right. Okay. So in order to create these different layers, okay, we use the symbol plus, which we will look at very soon. Okay. So when you put in the so we first of all we need to have a basic template of ggplot. Okay. And then we add on another layer using the plus symbol. Okay, so what we need to have, okay, in your basic ggplot function is you have to define, first of all, the data frame that you want to use to plot your figure. Okay, so in this case, the data frame that I am using, okay, is the surveys complete data. Okay, so you don't need to have the open quotes, the double quotes, okay, around your surveys complete here. Okay, so once you have your data input, okay, what you need to specify next in your ggplot is the axis. Okay, so what will make up your x-axis and y-axis? Okay. So we need to set, or we need to define the mapping variable. Okay, in this case, you have the, okay, the x-axis, okay, which equals to something something, and the y-axis, which equals to something something. Okay, so we'll put in the actual names of the axis very soon. Okay, but now I'll just leave it as unknown. Okay, so that is a very basic template for ggplot. Okay, it allows you to make the very first layer, which has your two axes, x and y. Okay, and the next thing is, let's say if you're making a scatter plot, okay, you have to give in the type of geom. Okay, so if I type in geom, okay, you get a whole lot of different options available. Okay, let's say if I look at germ bar, it will make a, oops. Okay, if I use germ bar, okay, it will basically make a bar chart for us. Okay, and if I use a box plot, it will basically make a box plot. Okay, but in this case, we want a scatter plot. Okay, so scatter plot will be, let's see, it should be germ point. Okay, so if we read the description for germ point, okay, the germ point, the point germ is used to create scatter plots. Okay, scatter plot is used to display a relationship between two continuous variables. Okay, which means variables in numbers. Okay, so let's choose this one. Okay. Okay, so next we have to decide. Okay, so we have laid out our template to make a scatter plot. Next we'll need to decide which variable from the which column, okay, from our data frame that we're going to take to make our plot. So if we go back to the surveys complete data, let's see what do we have here. Okay, so we are making a scatter plot of two continuous variables. This case, let's choose the, okay, so let's choose the weight, okay, the weight and the hind foot length. Okay, so we will have our weight variable as the x-axis. Oops, sorry for that. Okay, and then the y-axis will be the hind foot, length. Okay, so both of these are continuous. Okay, they are numbers. Okay, so if I run this, let's see what happens. Okay, so if it runs successfully, okay, something should pop up on your right-hand panel under plots, okay, automatically. So you can zoom in, okay, if it's too small to look at. Okay, you can zoom in your plot, okay, and it basically shows you a scatter plot of weight on the x-axis, okay, and hind foot length on the y-axis. Okay, so yeah, this pretty simple plot, pretty basic as well. Okay, just to show you how you can make a scatter plot in this case. Okay, so there are several things that you can customize. Okay, like let's say if you don't like the colors of your data points, you don't want it to be black, you want it to be red, you want it to be yellow. You can't change the color. Okay. or if you want, because the axis label is a bit small here. Okay, so if you want to make the size, the font size of your axis labels slightly bigger, you can also customize that. Okay, or you can also make what do you call this? The axis numbers bigger as well. Yeah, these ones. Okay. So there are a lot of the good thing about ggplot is it allows you to customize a lot of stuff. And if you want to apply the same customizations to a different plot, okay, let's say you want to make a new plot 5 months later, okay, on a different data set, you can copy the codes and apply it on a different data set, okay, without having to reconfigure all the customizations. Okay, so that's the good thing about using ggplot in R. Okay, I think I've talked too much. Okay. Okay, so what's next? Let me just true. Okay, so yeah, before we proceed, I just want to save this plot into an object. Okay, so let me save this into just name it as service plot. Okay, so I'm just going to move this into a different line. Right. Another important thing is when you are using the plus symbol to create a new layer, okay, or to add a new layer to your ggplot, always remember to put it after your first function. Should I say first function? Yeah, so it must be after your previous function. So something like this. So I can move this down a line, okay? But I can't move the plus sign along with the germ point, along with my next function to a second line. Okay, if I run this, it will give me an error because the position of the plus sign should be right after or on the same level as your first function. Okay. So if I run this, now it doesn't give me any error, okay, because it's in the right position. Okay, so yeah. So that's how you can make a simple scatter plot using ggplot and then specifying the germ type, okay, for scatter plot. Okay, so I guess, yeah, it's right on time. I think we should have a short break now. It's 9:50. Right, so before we go into short break, I have a question in the Etherpad, actually. Yeah, it's a very short. It's supposed to be a warm-up question, but yeah. Let me see. Okay. Yeah, so there's a warm-up question in the Etherpad. Okay, so what kinds of plot do you usually make to visualize your data? Okay, I'll just post this in the chat as well. Yeah, right. And yeah, so if you have any questions up to this point, please put it in the chat. Okay, if not, we'll have a short 10 minutes break, and I guess we'll reconvene at 10:01. Is that all right, Angelique?
That is perfect.
Okay, I'll just stop sharing. All right, I'll see you in 10 minutes. All right, so I hope everyone had a nice break. So let us continue from where we stopped at just now. Okay, let me just share my screen again.
Sorry.
Oh, yes.
Yeah, do you have the codes, the red written one? I can't
Oh, yes.
see
So,
the-
yep. So you can actually find the codes on the Etherpad. I've posted a message in the chat. Are you looking for the previous code that we run?
No, the current.
Yeah. So the ones we run just now. Yep. So you can find it at the almost at the very end. Okay, in the day 5 workshop.
Oh, I see it. It's there.
Yep. Okay. See. Okay. Right. So I hope my screen is showing up on the other side. Okay, so just a bit of recap. Okay, so we have just run how we can first of all convert a data frame from either a wide format to long format, okay, or from a long format to a wide format. And very often, if you are using ggplot, okay, you will have to convert your data frame from a wide to a long format. Okay, so which means you have to squish your columns into less columns, okay, before you actually use your data to plot to make plots in ggplot. Okay. And then we look at how you can export and save your data using the write CSV, where is it? Yeah, write CSV function. Okay. And then provide a file name. Okay. And you can also specify the folder that you want to save it into. Okay. And then next, we look at how you can make a simple scatter plot, okay, which has two continuous variables using ggplot, okay, specifically using the germ point function. So you have different germs. We look at the other, I think, 2 other germs later in today's workshop, okay, which will allow you to plot a bar plot, I guess. Are we going to do bar plot? Okay, but anyway, so we'll look at a few different types of germs, okay, in the later section of today's workshop. Okay, so if we go back, okay, one step to the last code that we run, okay, or the last figure that we made, okay, in this code here. So if I run it again, yeah. Okay. So if you want to visualize your plot, okay, you can run the name of the object that you save the plot to. So if I run this, okay, this is what our plot looks like. And you can straight away see what's the issue here. So the issue is we have too many data points. Okay, so if we go back to the data frame itself, okay, you'll see that it has 30,000 entries or 30,000 rows, okay, which means it will generate 30,000 data points on your plot itself. Okay, where was it? Where's my, I think I lost my plot. Okay, so yeah, this is the plot. Yeah, so yeah, the main issue here is you have too many data points and it kind of they kind of all being squished together. Okay, which means that you actually see less data points than the actual number of data points that should appear in your plot. Okay, so this is what we call overplotting. Okay, and overplotting usually occurs when you have a large data set. In this case, you have 30,000 data points. Okay, so yeah, this is a common issue in when you're making scatter plot. Okay, with a large data set. So it's okay if you have a small data set, let's say less than 100 points. But in this case, you have a significant issue of overplotting. And to solve this overplotting issue, okay, there are a few ways. Okay, so let's see. So we'll have a quick discussion, okay, on what do you think are some of the ways that could help you solve the overplotting issue. Okay, so I'll post the question on the, I think I have the question on the Etherpad. Let's see. Right, so we have a quick group discussion. I don't think I'll set up a breakout room, okay, but just a discussion, which you're free to post your thoughts in the chat box, okay, on how would you solve the issue of overplotting. Okay, so how can you make overplotting less obvious, or how do you reduce overplotting? All right, so we have, yeah, we could reduce the size of points. That's actually a good point. Okay. Let's see. Okay, I lost my plot again. Yep, so yeah, so one way is actually to make your points smaller. Okay, but there is a limit to how small your points can go. Okay, until it becomes invisible. Okay. Average sum data points close. So yeah, so what we can actually do is we can shift the points slightly, which means we can move the points. We can introduce some space in between the points to make them less crowded. Okay, and I'll show you yeah, pretty soon how we could do this using the drone jitter function. Okay, right. Any more thoughts on how we could actually reduce overplotting? Okay, so I'll just give yeah, probably one more minute, okay, for the discussion to go on, and then we'll look at what are some of the ways that we could use to solve this issue. Okay, increase the X and Y scales. Yeah. Okay, so you could do that. But yeah, the thing is, okay, so what you can do is you can expand, you can probably expand the scale, or what you're doing here is actually like make it wider or pulling it wider. Okay. Yeah. So yeah, you can expand the scale, but if your plot itself is already small enough, yeah, it's pretty hard to expand the scale, and there's a limit to the actual size of the plot that you can make it, like the actual, yeah, how big it can go up to. All right, yeah, so let's look at some of the, so thanks for the comments and thanks for posting all the thoughts in the Etherpad. So let's look at some of the ways that we can reduce overplotting. Okay, I'll just cross this out. Okay, so one way is to reduce overplotting is to make your plot into a slightly different shape, and also to set. Okay, so one way is to actually, a simple way is to change the transparency of your data points. So if you set the data points where darker color points have a higher frequency. Okay, so it actually it could help distinguish between those points with a lower frequency to those with a higher frequency. Okay, so what I'm trying to say here is you can set the transparency of your points, okay, where the darker the point, the more frequent it occurs. Okay, so to set the transparency, okay, what you need to do is you just have to add one thing into your original, oops. Let me copy this. Okay, into your original code, okay, your ggplot code. This is a bit okay, it's okay. Yeah, so this is the original code that we run, which gives you this. Okay, to change the transparency. So by default, I think it is 1. Okay, so that means there's no transparency at all. Okay, all the points are the same color. Okay. To set the transparency, you can use the alpha variable. Okay, so I want to make it less, more transparent. Okay, I mean less darker. Is that the right word? Okay. Anyway, so I want to make the points more transparent. Okay. So what I can do is I can set the alpha to a lower number. Okay, so the lower the value of alpha, okay, the more transparent the point is. Okay, so it basically sets the darkness of the point. Okay, so if I run this, let's see, I'll just run. Yeah, I'll just add version 2. Okay, right, so I'll just run this. Okay, and I'll call out my version 2 plot. Okay, so let's look at the difference between our original plot and our new plot here. Okay, so let me zoom this. Okay, so yeah, so if you look at our new plot, okay, we have slightly more transparent, okay, data points, and the points that are darker, okay, they are occurring at a higher frequency than the ones that only occurs once or maybe twice. Okay, so this helps slightly. Okay, this helps a bit. Okay, it helps to differentiate the points at the edges, I would say. Okay, like all these points on the edge, but not really the points in the middle. Okay, so the middle part, all the points are still stacked on top of each other. Okay. Yeah, so this is a way, okay, if you have, let's say, maybe a scatter plot that doesn't really look like this, maybe a scatter plot that is more white, like spread out. Okay, but this is one of the ways that you could use to reduce overplotting. Okay, so a different way is to introduce more space in between the points. Okay, so to do this, we use a different geom. Okay, instead of using geom point, okay, we use a different geom. Let me just copy this part. Okay, I'll just leave a comment here. So the first method that we use to reduce overplotting was by setting the transparency of data points. Okay, and then the second method is to introduce spaces between data points. Okay, so to introduce spaces, okay, we use a different geom. Okay, so it kind of produces a similar plot as scatter plot, but in this case, it allows more space in between the points. Okay, so what we're using here is the geom jitter function. Okay, so if you read the description for geom jitter, it is a convenient shortcut for germ point. So that means it's pretty much similar to germ point, but then it adds a small amount of random variation, okay, to the location of each point, which means it basically shakes your points a bit, okay, or it adds jittering to your points, okay. So if we run this, just move down a bit. Okay, if we run this, okay, let me just rename this version 3. Okay, run this, and let's look at our third plot this time. Okay, so it kind of doesn't do anything useful, but if we look back at our, let's see, when is the first one that we have made? Okay, so if we look at the very first plot, okay, that we have made, just this one, okay, versus this one. Okay, I think it kind of makes it worse. Okay, but anyway. Yeah, but yeah, the thing is, the point is that if you compare this one to your very first plot, it actually kind of separate out the points a bit more. Okay, although it's still kind of clumped together like in a bunch. Okay, but if you have a less crowded scatter plot, you can use germ jitter to reduce the overplotting issue. Okay, but in this case, it's a bit it's not really helpful here. Okay. Okay, so that's a question in the chat. The jitter function to make the data points smaller in diameter. Not really. No, not really. Okay, but you can make the data points smaller. I think we'll look at that soon. Okay, how you could customize the size of your data points. Okay. Okay, so yeah, so that is another way, I guess, yeah, to kind of solve or reduce overplotting. But this one uses a different package, so which means you have to install and load another package in order to run this code. Okay, so this is the this package that we're going to use here is called the Hexbin package. Okay. If you don't have it installed already, okay. Let's see. So I'll just type in the name of the package here. So it's called Hexbin. Okay, so I think I've already have it in my, let me just check. Packages. Hexbin, yep. So I have it in my RStudio already, okay, because I've installed it the last time. Okay, I don't know when. But yeah, so I have it already with me. Okay, so I can just load it either by clicking this, okay, or running this code. Okay. Okay, so but if you don't have the Hexbin package installed in your RStudio, you can install it now. Okay, I don't think it takes up a lot of time. So install packages, okay, double quotes, Hexbin. So if you run this, it will install the Hexbin package for you. Okay, and then you can load it into your environment. Okay. So once you have this package loaded, okay, what you can do is, so if we go back to the survey plots, okay, and I'll just copy this here. Okay, so basically, yeah. So basically, the survey plot is the same as the code chunk that we run, okay, to produce this figure. Okay. And what we want to do now is we want to transform this current figure that we have into a slightly different appearance, okay, using one of the functions in Hexbin. Okay. So the function that we're using here is called geomhex. Okay, so it's this one. Okay, so if I run this, basically I'm adding a new layer, okay, which will slightly change the appearance of my current plot. Okay, if I run this, okay, so it gives us a pretty cool hexagonal plot. Okay, where I think so if you have regions of higher occurrence, okay, where your data points occur more frequently, okay, it will show up in a slightly lighter color. Okay, so this region is having more data points, and then you have this concentrated region, and so on. Yeah. So it kind of produces a scale which tells you which regions are more concentrated with your data. Okay. Yeah, but I wouldn't say this is the best option to produce figures for publications. Maybe just for you to visualize it for your own purpose. Okay. Yeah, but it's pretty cool. Yeah, you could try this next time if you're making a scatter plot. Okay. Okay, let's see. What's next? All right, so we'll look at a few different customizations. Okay, so I've firstly mentioned a few things that you can change to your plot, such as the colors of your data points, or the size of your data points as well. And then after that, after looking at these small things, we will try out an exercise. Okay, so you get the chance to make your own scatter plot using a different set of data. Okay, so instead of using the weight and the height with length, okay, we'll use a different set of data from the same survey's data frame, okay, to make a different scatter plot. Okay, and then I'll also show you after that where you could get some of the so there's a website that offers very useful or basic templates to build some common R plots. Okay, so I'll show you up next. Okay, but yeah, so let's just look at how you can customize some of the what do you call that? Some of the things in your ggplot first. Okay, so let's see how you could change the color, customize the colors of your data points. Okay, so if I go back to my, let's see, my very first code, I think it's this one. Just copy this. So this is the basic template to make the scatter plot. Okay, guess I should just put this down so it's easier to read. Okay, so this is the basic template, okay, that we used just now, okay, to make this plot over here. Okay, what if I want to change the color of my data points? Okay, what if I don't want it to be black? Okay, so to change the color, you can add in the color variable. Okay, so in quotes, this is where you put in the color that you want. So the later version of R, okay, I think it was introduced about a year ago. Okay, this later version of R allows you to visualize the color itself once you have typed out the name of the color, okay, or using a color code. So let's say if I want to change it into blue, okay, so when I type in the name of the color, okay, blue, it will automatically show up in the code itself. Okay, so this allows you to visualize the color before you actually make your plot, okay, which is a cool function. if I run this, okay, and if I look at my survey plot again, this time it's blue. Oops. I think someone's
Yeah, I'm trying to mute, but it's not working.
it's okay. Yeah, I just want to check if it's the questions.
Maybe. Let me go. Can you try and mute, Gia? For some reason, I can't mute them.
Where is it coming from? Yeah,
It's
I think
Tajudeen. There we
okay,
go. I think, yeah.
I'll try to. No, I don't think I can do. Okay.
There we go. It's muted. Yeah.
Okay, right. Okay, sorry for the interruption. Okay, so yeah, so this is how you can customize the color of your data points by adding the colored variables in your function. Okay. If you don't want a set color, so which means if you don't want let's say the basic colors like blue, red, gray, yellow. If you want something more fancy, something in between, like from a color scale or color palette, that is a very nice website. Just go to called Coolers, which I use pretty often. Okay, just copy and paste this in the Etherpad. Okay, on the alternative color palettes, I'll also paste this in the chat. Okay, so Coolers has there's two options to get colors. If depending on if you want just a single color or a color palette. If you want a color palette, you can use the palette generator. Okay. So if you want 5 different colors, or if you just want 4 different colors, it depends. If not, you can go to this page, okay, where you can choose whatever color you like, or you can type in the name of the color. So let's say if I want green, green, then it will show up a bunch of like different scales of greens. Okay. So what you can do is, let's say if I want, let's choose a nice one, peach color. All right. So let's say if I want this color, I can just click on this. Okay, so it's we call this a color code. Okay, I think it's called what do you call this? I don't remember. Okay, but it's a code for colors. Okay, and if I put this with a hash in front, okay, it will show up the color that we are using, okay, in our data point. Okay, so if I run this and look at the plot, yep, so it shows me a different color this time. Okay. Yeah, so Coolers is a pretty nice website to get that offers slightly more options for colors. Okay, instead of just the typical basic colors. I think there is also some options for color palettes in R as well. Okay, like you have different packages that offers different color palettes, okay, in R. Okay, so this is how you can set the colors, okay, by giving in the name or the code of the color that you want. Okay, but a different way, okay, or a different thing that you can do is to set the color of your data points based on one of the variables from your data frame. So let's say if I want to set the color of my points according to the species. So I want points that belong to the same species, having the same color. So I have, I think, a few different species here. Okay. Right. So if I, let's see, so if I run this, what's my data? Surveys complete species ID. Okay, so if I run this, it will show me, it will print out a list of the different species ID that we have from our data frame. Okay, where's my species ID? Yep, here. Okay. So in total, we have how many do we have? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I think we have 14 different species ID, and I want to color my data points according to these different species ID. Okay, so I'll just copy this and paste this here. Right, I'll just add a title. Color points according to species ID. Okay. And what I'm going to change here is this part. So instead of using the color variable, okay, I'm going to add in this one. Okay, and what I'm going to put here is I'm going to set it as species ID so that it colors the points according to this one. Okay, so if I run this, let's see, and the plot. Okay, so now we have a plot that looks like this. Okay, where all the points are colored according to different species ID. So you should be able to see 14 different colors, okay, because we have 14 different species. Yeah. Okay, so this is how you could distinguish your data points based on a certain variable, okay, from your data frame. Okay, which is a pretty cool function and is often very useful in when you have an experimental data set and you want to look at maybe the differences between this sample this sample set and a different sample set. Okay, maybe the control versus the the positive group, something like that. Okay. Okay, so we have looked at how you can customize some of the stuff in your ggplot. Okay. Next, we're gonna have a very short exercise. Okay, some activities where you are going to make your own scatter plot. Okay, so previously we made a scatter plot, okay, using weight as the x-axis and hind foot length as the y-axis. This time we are going to make a we're going to make another scatter plot. Scatter plot using the same data, which is your surveys. I think I should have a comment here. Surveys. Was it survey? Yeah, surveys complete. Okay, but this time, okay, I want you to plot, let's see. Okay, so what should we have in our scatter plot? Okay, so let's have weight, using weight and species ID. Okay, and also I want you to color the points according to the plot types. think it was plot type, was it? Plot type, yes. Okay. And once you got your scatter plot, think about if this is the best way to visualize your data, okay, to visualize the relationship between weight and species ID. Okay, so weight will be in the y-axis this time, and species ID will be on the x-axis. Okay, just copy this and put it in the Etherpad. Just go back to the Etherpad. Oh, okay, so I have my question here. Yep, so the question is already on the Etherpad. Just leave some space. Okay, so yeah, so let's have 5 minutes for this short exercise. It's now 37. What time is it now? I'm trying to convert the time from Melbourne. So it's I think it's 10. Yeah, it's 10:30 now. Okay, so yeah, so let's give it 5 minutes, okay, for you to try out this exercise, and you can, right, so it's 38 now. Okay, so let's give it 5 minutes to try this exercise, and you can, after that, you can post in what do you think about your plot. So do you think it is a good plot? Is it a good way of showing the data that you have? Or do you think there are other options that are more suitable to make to visualize your data? Okay, so I'll see you in 5 minutes. Okay, so a bit of hints here is that to make your scatter plot, okay, you can refer back to this code here. Yeah, I think it's a pretty obvious hint. Yeah. So I think to make this plot, you should have everything that you need, okay, in this code. Okay, so I saw someone typing in the pet. Okay, we'll just go back to the RStudio. Okay, so to make the scatter plot, okay, easy way is to just copy this and I'll just paste this in. Okay, but there are some things that you need to change, okay, which is first of all the axis, so the y-axis and the x-axis. X-axis would be species, species ID, and y-axis would be weight. Okay, and then because you're giving the color based on the plot type, so I'll just replace this with the plot typed column. Okay, so if I run this, let's see, what do we get? So we get something like this, which is if you compare this one with the previous plot that we have, it gives you a kind of a very different pattern, okay, of how the points are distributed. Okay, so in this case, the points are distributed on a vertical basis. Okay, so all the points, they are distributed along the x-axis, so along each of these different species ID. Okay, the reason being species ID is a categorical variable. Okay, it is not continuous, unlike in the previous plot where we have both continuous variable. So this is the major issue here. Okay, because if you remember, scatter plot is more suitable when you have two continuous variables. Okay, so what if you have a categorical variable? It wouldn't be exactly wrong, but it wouldn't be that appropriate to use a scatter plot, okay, for a categorical variable. Okay. Okay, let's go back to the type. Okay, so then how could we improve this plot? That's my plot here. Okay, so how can we improve this plot over here? If you look at the pattern of this plot, it kind of looks like a, yep. So Peter has a suggestion. So can we use a bar? So yep, that's yeah. So that's actually something that we're going to use next. Thanks, Peter. Yep. So an alternative way of showing your data, okay, because you have categorical and continuous, is to use a bar instead of a scatter plot. Okay. So yeah, this is also something that we're going to look at next, how to make a bar plot. Okay. So yeah, making a bar plot. Okay, so for bar plots, you usually have on your x-axis categorical, and on your y-axis a numerical or a continuous data. Okay. Okay, so to make a different type of plot, okay, previously we are looking at scatter plot and we use the germ point function. So if you're making a bar plot this time, we will be using a different germ function, okay, which is I think it's the germ bar. Okay, right. Pretty self-explanatory. Okay. So let me just okay, I'll just make a new code here. Okay. Okay, so how do you make a box plot template? Okay, I would say it's almost the same as when you're plotting a scatter plot. So you have your ggplot, so you start with ggplot, okay, and then you have your data. Okay, what is the data frame that you're going to put in? So we're using the same surveys complete data frame. And then you have your x and y axis, which you need to define. Okay, so mapping goes to aesthetic x is so I'll just copy this here. Okay. Okay, so you have your axis layer, okay, your ggplot layer. And next thing is we will be using this geom box plot. Okay, so it's geom box plot. It's not geom box. Okay. Geom box plot. If I run this, okay, this is the plot that it will generate, okay, for us. Okay, and I want to save this into a new R object. So let's give it surveys box plot. Okay, just move this down. Okay, and then I'll just call out the plot, box plot, yeah. Okay. Yep, so if you look at the box plot, you might see some plots, some data points outside of your box plot. So these data points are the ones that are not in the box itself, I would say. You can view them as outliers, kind of. Okay, so if you want to remove these outlier points, what you can do is you can add in something, okay, in your original box plot code, okay, to remove the outlier points. So I'll copy this again. Okay, and then this time I'll put in, I think it should be outlier shape. Okay, so if you read the description for outlier shape, it tells you that it helps you to hide the outliers, okay, close to any. So run this, then run the plot. So this time, oops, the outlier points disappeared. Okay, they are no longer in my box plot. Okay. So that's a very basic box plot. Okay, a simple way where you can make a box plot with categorical and continuous variable. Okay. So sometimes you might want to overlay data points on top of your box plot. Okay. So maybe not in this case, because if you look back to the, run this again, not this one. If I run this again. Okay, if I run this, the points are pretty close together. Okay, so it's not that easy to differentiate between individual points. But sometimes if you have more spaced out points, you can add these points on top of your box plot to just look at the distribution of your points. Okay, so to do this, you can add a layer of your geom points on top of your geom box plot. Okay. So what we are doing here is we are adding data points on top of the box plot. Okay, so I'll copy my old code for the box plot. And then I'll add on a new layer with the plus sign. Okay. Let's use geom jitter in this case. Okay, so I'll just quickly set it to a different color. Okay, color, let's use blue. Okay. Okay, so I'll run this and let's see what we have got. Oops, it doesn't look good here. Okay, so yeah, I think the color is pretty much shading the box plot. Okay, so what I'll do is I'll adjust the transparency to make it more transparent so that it doesn't cover the box plot. 0.3. Okay, it kind of looked better this time. Okay, but yeah, you can see the points are still kind of overlapping, okay, over the box plot, okay, because it's too dense. But yeah, but this is a way where you can show your data points, okay, or show the distribution of your data points on top of your box plot, okay. It'll be more useful if you have a less dense plot. Okay, so what if you have instead of having your germ jitter layer, okay, after the box plot, what if you have the germ jitter layer before the box plot? So what do you think will be different in your final plot? So let's move this on top. Okay. Okay, and if I run this, okay, so this time it looks slightly different, okay, because we have rearranged the different germ layers. We're putting germ jitter first, and then after that it's germ box plot. So what this basically does is it will plot the data points first, and then it will add on the box plot on top of the points. Okay, so layering in ggplot is pretty important. Okay, so how you layer your plot, okay, or the sequence of layers will determine the final order of your plot, okay, or how it appears. Okay, so that's pretty much all that I wanted to show for box plot. Okay, so first there's also other functionalities that you can customize in box plot, I'm pretty sure. If you're interested in more, you can always look it up online. Okay, Google it. Okay, I usually Google the functions that I need when I need them. Okay, I don't try to remember them here for most of the additional functions. Okay, so let's see. Yeah, so this is a box plot. Okay, but what if you want something that shows the shape of the distribution of your points? Okay, so that is a different germ. Okay, kind of similar to box plot, but then it will show the actual shape of your data point distribution. Okay, this is what we call a violin plot. Okay, oops. Okay, so to make a violin plot, you just have to replace the germ box plot. Where was I? It's here. No. Okay, let's take this one. So I'm taking the template for box plot. Okay. And I am replacing it with a different germ, okay, which is germ violin. Okay, so if I run this, and if I look at my point this time, okay, this is slightly different from box plot because it shows how the points are distributed. Okay, where do you get the most dense points? Okay. Yeah. So this is an alternative to box plot. Okay, if you want to know like how your points are, what's the shape of the distribution of your points? Okay, so depending on the purpose of your plot, what do you want to show? You can either use a box plot or a violin plot. Okay, so I should rename this as violin plot. Okay, that looks better now. Okay, and of course, you can also add a layer of data points on top of your violin plot by adding plus, and then in the next line, germ jitter. Okay, yeah. Okay, so what's the time now? All right, so I think we'll have a very short activity, okay, another exercise for box plot, okay, before we go into our second break. Okay. All right, so we have looked at how you could make box plot. And now let's try making a different box plot. Okay, so this time let's try to make two. Okay. So I want you to try to make a box plot. Let's see. I think I have let me just check the Etherpad. I think I have the question here. All right, so yeah. So in this activity, I want you to try to make a box plot, okay, for hind foot length. Okay, so which means you have hind foot length, okay, on your y-axis. Sorry, y-axis, and on the x-axis it's the same. Okay, so you use the species ID on your x-axis, okay, as previously. Okay, yeah, and then once you got your box plot, okay, I want you to add a layer of the data points, okay, using geom, the right geom, okay, to show the actual measurements. Okay, so let me just copy this, paste this into RStudio. Okay, so let's give it maybe 3 minutes. Okay, so you should be able to look for all the codes that will make the plot for you. I'll just copy these. Just copy these codes onto the pad. Whether they stop just now. Okay. Let's move this. Oops. Right, so you should be able to find all the codes that we have just run on the Etherpad. Yep, so don't worry about the outliers. If you have any, you can just keep them in your box plot. Right, so I just want to make sure everyone's on track. So if you have any questions, please feel free to put in the chat. And I think we have a few helpers, and yeah, to attend to any questions in the chat. So it's been pretty quiet today. Yeah, since the morning. Okay, so we'll be discussing the exercise in maybe 1 minute more. Okay, so I hope everyone managed to get the plot. So we're making a box plot here for which have the y-axis represented by the hind foot length, okay, which is a continuous variable. And then on the x-axis, we have the same species ID as previous. Okay, so to make this plot, you just have to go back to, let's see, right, okay, the very basic template code that we have. Okay, and then we have to change the y-axis here. Okay, hind foot. Oops, spelling error. Length. Okay. And then box plot, so everything's fine. And then we have to add on a layer of data points. Okay, so we'll use your jitter. Oops. Okay, and I'll just set the transparency so that it's not overlapping a lot. Okay, 0.3, we fine. I'll just set the color as maybe a different one this time. Let's try green. Okay, if I run this, let's see. Okay, it's pretty, yeah, it's not looking that nice, but this is what we get, okay, by running the code. Okay, so yeah. Okay, so yeah, so that's basically kind of similar to what we have just made, okay, in our previous plot. Okay. So let's say what if I have species instead of species ID? Okay, so if you look at the species column, okay, yeah, it kind of have the complete name, okay, the full name of different species. Okay. So if I just copy and paste this, okay, so okay. So what if I put species instead of species ID as the x-axis? Okay, and I make this plot here. Okay, so I'll just zoom in. Okay. Yeah. So one problem here, okay, if you look at the x-axis, the species axis, is that some of the species names, they are kind of overlapping each other. So like this one here, they're kind of moving into the next name. So what you can do is you can rotate the labels on your x-axis, okay, by in this case, let's rotate it by 90 degree. Okay. So what I'll do is I'll add an additional layer, okay, which helps me to rotate the x-axis labels. Okay. So what I use is the theme function, and there's a lot of different utilities in the theme function. Like you can set the axis labels, I think, yeah, axis labels, titles as well. But we're going to set the text, okay, for your x-axis. Okay. And we want to change the angle of these texts. Okay, so element text, angle 90. Okay, so this is actually part of a later section, but I'll just show you how you can run this, how you can rotate the axis labels to make your plot more readable. Okay. Okay, so what we're doing here is we are rotating your x-axis labels, okay, by 90 degrees. So I'll run this and let's see what's the difference. Okay, so you'll see that all the names here on your x-axis, they are being rotated 90 degree. Okay, so it makes it easier to read this time because they are not overlapping anymore. You can do the same for your y-axis. I think you just have to change the axis.text.x to axis.text.y. Okay. So usually if you have the option for x-axis, you should have the option for y-axis. Okay. Okay, so yeah, so I think the time now is 11:08. Am I right?
Yep.
Okay, so should we have a short break? A 10-minute break? All right, so let's have a short break. And I'll see you in 10 minutes at 11:09. 11:19, sorry. Okay, so it's 11. I guess 11. Let's see. 11:19. Right on time. I posted the codes that we have just run in the Etherpad, so you can find all the codes, the previous codes, and which leads us to the plots that we have made. All of them are available on the Etherpad. Okay. So a recap from the previous session is we have to look at how we can make go back, how we can make bar plots. Okay, so bar plots are usually when you have categorical variable versus continuous variable. Okay. An alternative for bar plot is the violin plot. Okay. Which shows you the distribution of your data points. Okay. For instance, if you have a denser distribution of data points in the lower half or the upper half. So both box plot and violin plots are kind of similar. Okay, so it depends on which like the purpose of the purpose that you are looking for. So do you want just a simple box plot or do you want a violin plot? So there is also an option to include a box plot within violin plot. Okay, we'll look at that one. Okay, because I will show you a website where you could get really nice R codes for making different kinds of plots. Okay, and we will look at how you can actually integrate a box plot into a violin plot later. Okay, so up next, we are going to look at a very short section of this workshop, which is to make time series plots. Okay, so time series plots are plots that show you changes of a certain variable over time. So let's say if you wanted to look at the changes in the number of different genus, different species over time, you can make a time series plot. It usually comes in it can come in as a line plot. Okay, so you're making a line plot that shows the changes over time. Or I guess you can also use other different plot types to show the changes. Okay, so but here we are using we will make a line plot, okay, to show the changes in our data. Okay, so let's see. Okay, so let's take in this case, I want to look at the number of counts, okay, for each genus over time. Okay, so if you look back to your surveys complete data set, you have the genus versus genus, genus column. Okay, and you have the year column, which is the time data, okay, that we are looking at. So I want to know the changes in the number of different genus, okay, over time. So what I have to do first is I have to create a new data frame, which has the number of counts, okay, for year and genus. So to do this, I'll use the count function. So we have the surveys complete. I'm pretty sure you have used the count function in the previous workshop. Guess it was somewhere between day 3 and day 4. Okay. So count, what I want to count is I want to count the year as well as the genus columns. Okay. Okay. And then I want to save this, into a new R object. So let's give it a name, yearly counts. Okay, okay, right. So I'll run this and then let's view this yearly count object. Okay, so this is how a new data frame looks like. It basically shows you the different number of counts, okay, for each genus corresponding to each year. Okay. So for instance, for this, I don't know how do you pronounce this genus. Okay, it has 3 different observations, okay, in this particular year. And then you have different number of counts for the other different genera, okay, in different years. So we want to visualize these counts, okay, in a time series plot. And what we're going to do is we're going to make a ggplot, okay, with geomed line, okay, which will make a line plot for us. Okay, so starting with ggplot, remember what you have to put into ggplot. We start with the data first. Okay, so data equals not survey. Okay, this time data equals to yearly counts. So this is the data frame that we are using. Okay. And then we have the x-axis and y-axis. So x equals to so we are looking at year. Okay. Year, right. Okay. And then on the y-axis, we have, so on the y-axis, it's pretty tricky, okay, because you don't have the genus. Instead, you should have the number of counts, okay, because you're looking at the changes in the counts, okay, over the year. So the y-axis should correspond to the end column. Okay, so I'll put n here. And then we want to draw a line that shows the trend. Okay, so to make a line plot, I'll use geolined. That's geolined. Okay. So if I run this, let's see. So we get a pretty decent plot. Okay, although it looks kind of up and down and up again. Okay, but it shows you the how the trend changes. Okay, so how the number of counts change over time. But the problem here is the counts represent the total count. Okay, so you don't have individual counts for each genus. Okay. So in order to separate, okay, your trends, okay, in order to visualize the individual trends for each genus, okay, what you have to do is you have to add something into your code. Okay, so you have to find the data that you use, okay, and the x and y axis. Okay, what you need more is an extra specification, okay, which is the grouped. So by adding the grouped, okay, it will kind of what's the right word? It will kind of group the counts according to the variable that you specify. So in this case, we want to group the counts according to the genus. So each of these genera should have a different line, a different trend line. Okay, so we'll put genus into the group and we will run this code again. Let's see what's different. Oh, okay, so this time it looks better. Okay, so what you have is you have different trend lines, which each of these representing a different genus. Okay, the thing is, so you might have noticed that you can't really tell which line is representing which genus. Okay, they all have the same color. There is no label, okay, to tell you which of these represent which genus. Okay, so to to differentiate the lines, the trend lines, according to color, here you can add a color specification, or instead, not add, but you can change the group specification here in your ggplot into color. Okay. Probably I'll just copy and paste this. Right, so if I change my group specification to color and run this time it looks better because it tells us exactly which trend line corresponds to which genus. Okay, and this is what we want to show in our plot. Okay, and then you have this legend over here on the right, okay, which tells you which line is for which genus. Okay, so everything's looking pretty good. This is how you could make a time series plot. Okay, I'm pretty sure there are other options. Instead of using a trend line, you can use a different kind of plot as well. I think a scatter plot might work. I don't usually make time series plots, so I'm not really an expert in these kind of plots. But yeah, so this is just a very simple walkthrough of how you can make time series plot. Okay, using ggplot and germline. Okay, so the next thing that I am going to show is a slightly different way of integrating your data frame into the ggplot function. So all this time we have looked at how you could specify the data frame inside your ggplot function. Okay, so which data frame you should use to make your plot. But what we have been doing so far is we have been adding, or we have been specifying the data frame inside the ggplot function. Okay. Another different way that I personally would prefer is to specify the data frame outside of the ggplot function. Okay, because it makes it less clutter, I would say. Okay, but that is just my personal preference. Okay, it's not a right or wrong answer. Okay, you can use whatever syntax that you prefer. Okay, but I'll just show you how we can do this without specifying the data in the ggplot function. So to do this, we use the pipe operator. Okay, so I'm going to show how you can use the pipe operator to integrate, okay, your data set into ggplot. So usually we have something that looks like this. Just copy. Okay, I'll take one of the codes that we run. Okay, let's take the one for time series. Okay, so instead of having my data specified inside ggplot, okay, what if I move it out? Okay, so I can do this by putting my data frame outside. Okay, so I'll start with the name of my data frame, which is the yearly count, this one. Okay, and then followed by a pipe operator. Okay, and I'll just move this to the next line so that's easier to read. Okay, so if I run this code, okay, let's see. It basically makes the same plot for me, okay, but in a different syntax. Okay, in a way it's more readable. It's cleaner, I would say. Okay, especially when you have, let's say, if you have a very long ggplot function. Let's say if you have other specifications in your ggplot, this might be a cleaner way of representing your R code. Okay. Yeah. Yeah. But the only thing is, don't get yourself confused between the pipe operator, okay, and the plus symbol. So you use the pipe operator when you are piping or connecting something, in this case, your data, into the next function. Okay, but when you're using the plus symbol, the plus symbol is for you to add a layer of, usually a layer in ggplot. Okay, for instance, a layer of data line, or layer of data points, or a layer of box plot. Okay, so yeah, so it's important to not be confused between using the pipe and the plus symbol. Okay, especially in ggplot. Okay. Next thing is I am going to show a very useful function, or I would say it's something that allows you to split a single plot into multiple different plots. So let's say if I run this, okay, this is the second time series plot that we made just now. Okay. If you look at this one, we are having all the trend lines in a single plot. But what if I want each of these lines to be in a different plot? So which means I want 14 different plots, okay, each having a different trend line, okay, for the genus. Okay. To do this, I can use what we call faceting. Faceting plots. Okay, so faceting basically means you are splitting a single plot into multiple different plots. Okay, especially on the basis of a certain variable, in this case, genus. Okay, or something else. Okay, so let's say if we want to split. Okay, so we want to split this plot. Okay, the one that we have, into individual plots. Okay, so how can we do this? So let me just copy the code I have. Let's use this one maybe. So this is the very first time series plot that we have made. Okay, and it looks like this. Okay. And what we want to do is we want to facet. I'll just add a comment here. Time series plot. Okay. And what we want to do is we want to facet the plot by genus. Okay. So let's see. Okay. Yep. So this is our data frame, and I want to split my plot, okay, into individual plots by genus. So what I can do is I can use the same. Oops. Okay, the same template. Okay, but remember to remove this group. Okay, we don't need the group specification because we are going to split our plots in the end. Okay. Okay, so what do we need to add below germline? Okay, after germline is the facet function. Okay, what we call facet wrap. Okay, and in the brackets, I will have to specify the variable that I want it to be faceted on. Okay. So it looks something like this, and then I want to facet it based on genus. Okay, I want to split my plot based on different genera. Okay, so I'll run this. Okay, so now you have different plots. Let's see, how many plots do we have? So we have actually 1, 2, 3, 7, 8 plots. Okay, oh, so it's not actually 14 plots. Oh yeah, okay, right. Okay, so we have 8 different plots, okay, each representing the trend lines. Okay, oh, each one showing the time series plot for each individual genus. Okay, so all these plots have the same x-axis and y-axis. Okay, just that they are being split according to genus. Okay. Yeah. So faceting is a pretty common utility in R. Okay, I would say I use it pretty much. Okay, whenever I'm making plots. Okay. Yeah, it has different uses, different usage. Okay, but it's pretty much a very useful function to have. Okay. So that is an option. Okay, if you want to split it according to, let's say, 2 different variables, I think you can do that as well. Okay, instead of just having one variable, in this case, it's the genus variable. Okay, so yeah, so this is how you can use the facet wrapped function to split a single plot into individual plots, okay, based on a specific variable. Okay. All right. So let's see what's next. Do we have time for the I think we do have time. So what's the time now? Just want to check if we have time. I think it's 11. Yeah, so we have an hour plus more. Okay. Okay. So right. So there are if you go to the Carpentry's website, I think the link is available on the day 5 section. Okay, it's not really that. But if you go to the lesson page, okay, under data analysis and visualization, the ggplot page, there are more details on how you could use facet wrap to play with your data. Okay, so this is just a very introductory example of how you could use the facet wrap function, okay, to split plots. Okay, so next thing is, so we have been looking at different customizations that you could add to your plot. Okay, we have looked at how you could facet plots and how you could change the colors of your data points. You can also change the colors of your line as well, okay, if you want. And how you could, what else? Let me just go back. Yeah, and how you can change the transparency of your data points, etc. Okay, so if you have looked at a few of these, okay, things that you can customize in ggplot. The other thing is, I guess most often you would want to change the background of your plot. So this is the default background. Okay, you have the kind of grid lines with gray background, okay, in the back. What if you want a different background? Okay, what you can do is you can set the theme of your plot. Okay, there are a few built-in plots available in R. Okay, so let's say if one of the themes that are often used is the black and white themed. Okay, which is, I'll just get one of these. Okay, just get this. Okay, so what I'm trying to do here is I'm trying to customize a theme for my background. So I'll use the same plot that we had just now. Okay. Let's say if I want black and white theme. I don't want a gray background. I don't want I don't like this color. Okay. What I can do is I have a few options for built-in themes in R. Okay. This is the most common, by far, this is the most common one that I use. Okay. Let's try this. Okay. So if I run this, okay, with an extra layer, okay, this will change the color of my background, or this will set a different theme to my plot. Okay, so if you want different other themes, I think there are pretty much a few. Let's try. What if I use dark? Okay, let's try the dark theme. I think this is pretty tricky. Yeah. Right, so this is another different theme. Right, so I would say the black and white one is most suitable for publication figures usually. Okay. Yeah. Okay, but this is how you could set different themes. Usually it changes the background. Okay, sometimes it changes how the axis or the titles labels appear as well. Okay. So if you're looking for a list of themes in R, that is a website. Let me see. Thing is called, just Google it. It's called GG Themes. Yeah, I think it's this one. Yep. So these are the different themes that are available in R. Okay. I'll just copy and paste this link into the chat and Etherpad. Where? Okay. All right. So I think it's already on the pad. Right. I'll just add it on the chat. Okay, so yeah. So that's a way, okay, that you could customize your own theme, usually by changing the background of your plot. So there are other customizations available in ggplot. Let's say if okay, so yeah, so let's say if you want to add a title. So in this case, we don't have any plot title, okay, in our plot. Okay, we have the X and Y axis, but we don't have a main title. Okay, so if you want to add a title labels, okay, add title labels, so labels, okay. I'll use back the same plot. I don't really like the dark theme, so just change it back to black and white. Okay, so I'll use back the same code that I've just run, okay, which gives me this plot. Okay, but this time I want to add in the labels. Okay, so I'll add it in between my just right before my theme. Okay, so to add labels, okay, if you want to add the figure label, okay, the main title, the title labels, or the X and Y labels. Okay, in this case, we already have the X and Y labels, but they are not really explanatory. So if you want to change these labels into a different ones, you can use the same function here, which is the labs or labels function. Okay, and the first thing we want is the title of our plot. Okay, so title equals to, don't forget the double quotes. let's give it title. So I'll just name it observe generate over time. Okay, so this will be our plot title. And then for the x-axis, I just want to rename my x-axis as year. Okay, with starting with a capital Y. And then for my y-axis, I want it to be number of individuals. Okay, so instead of and, I want it to be more explanatory, number of individuals. Okay, and don't forget your plus symbol, okay, because you have the last line here. Okay. Okay, so let's run this. And after running this, it should add a plot title, okay, as well as rename your X and Y axis titles. Okay. So yeah, so this is one way that you could add the labels for your axis and your title. Okay, that is an alternative, okay, which is by using the GG title function. So G title is a it's part of ggplot, I think, if I'm right. Okay. So alternative way is to use the GG title function. I'll just copy this code and then remove the labels. Okay. If you want to add a title to your plot, you can use GG title. Okay, and then you can put in the name, which is observed generate over time. Okay, and for the X and Y axis, okay, you can use a different function, okay, which allows you to change the axis labels individually. Okay, so for X axis, it was here. For Y axis, it was number of individuals. Okay, and then the plus sign. Okay, so if I run this, I should get something, I should get back the same plot, okay, as the previous one. Yeah, so yeah, you can use either one to add in labels. Okay. If you use this, usually I use this when I only want to change one of the axes. Okay. Yeah, but labs, the labs function is pretty much sufficient. Okay. Okay, and don't forget, if we look at this, yeah, plot, so this is not really, anyway. Okay, we have also looked at how you could rotate the axis labels, remember? Okay, we have tried to rotate it by 90 degrees just now, in one of the, I don't remember, one of the plots. Okay, yeah, I think it's this one. Okay, so you can use the theme function to rotate the axis labels. There are other options, utilities available for the theme function. I think there are a few, okay, quite useful. The theme function is a very useful function to have in ggplot. Okay, it allows you to customize a lot of stuff. Okay. So let's see what's next. I think we have just a few more things to cover. Okay, so we might be able to end it a little bit earlier. Okay. Let's see. Okay, so I guess this is probably the second last section in this ggplot workshop. Okay, so next
Yeah,
is,
we have two questions in the chat, one from
Oh, okay.
Peter.
All right, I haven't noticed it. Thanks, Angelique, for pointing it out. Okay, so Peter has a question. How to move the main title to the center? Okay. Okay, yeah. So to move it to the center, I'm pretty sure you can use the theme function. Oops. Sorry. So if I take this, let's see. Axis title, top right, okay. I think it's this one. Okay, let me just double check. Okay, yeah, so I think it's something like, so if we go back to, yeah, so you have to add element text. Oops. Text. Okay, and then, let's see, so you want to arrange it in the middle. So yeah, you could try to, let's try just 0.5. This work. It doesn't. It's not moved. What if I change this to 1? Okay, still the same. Oh, okay, but it's still the same. I'm pretty sure that's a function, but I couldn't recall it at this moment. Let's see. Angelique, do you remember what is the function that we use to set the position of the axis title?
Off by heart, no, but I'll quickly do a Google search.
Yeah, I would say do a quick Google search. We just try to Google it.
I found something by Stack Overflow. I shared it in the chat. I'll look for a couple more resources and share it with you.
Okay, great. Thanks, Angelique. I think it's, yeah, that was a good question because we often have to arrange the plot title. Let's say if we want to publish it. Let's see. Yeah, I'd say try Googling if you could find something that allows you to set the position of your axis title. I'm pretty sure that is a function. There's a way to do this. Okay. Let me just delete this. Okay, so Google is always, yeah, I would say always the go-to place when you have any questions. And there's also this Stack Overflow forum, okay, which usually, if I have any questions, regarding like R or other programming languages, I'll just move to Stack Overflow and see if anyone's posted some similar questions.
Yeah, and I think you got it right. You just needed to change the plot, axis to plot.
Axis plot.
Axis.title should be plot.title. That was the only change.
Oh, sorry. So yeah, so if you found the way, let's see. So let's see. So I'm sorry. I think I miss you. I miss what you said.
Oh, sorry, I was just saying, I think you wrote it correctly, except in the console, your console, the second line to the bottom, where it says theme axis.title in the console, it should say theme and then plot.title, and then everything will work.
Plot dot title. Oh, okay.
Yeah.
Oh yeah, it's
So
access.
plot.
Okay. Yep. I think this should work. Oops. Sorry. Okay, so let's run this. Hope it works. I don't. Probably not.
Yeah, because I tried your very script. I just changed plot and everything worked.
Oh, and it works. Okay. Right. Yeah, I think the best way is to Google it to see if that's yeah, a way to make it to set the position of the title. Okay. Okay. Oh, wait. Right. Okay. Yeah, but that's a nice discussion. Okay, we often have different questions, and yeah, it sounds like a very simple question and a simple solution, but then sometimes you just have to look for the like the way to change it.
Yeah, and your theme dot black and white, it should not come at the end. It will not go to the center. It should come somewhere, maybe after. You can put it after
Oh, okay.
facet dot wraps. Yeah, remove
The
theme underscore black and white and add to facet
okay.
dot wraps. Yeah.
Let me try this and then this. Does it work? Team plot. I've changed it back to axis title. No, I think the position has changed.
It should be plot dot title.
Oh, plot dot title. Okay.
You
No,
need a plus after. You need a plus after black and white. Theme dot black and white.
oh, okay.
Uh,
Yeah, I missed that. Sorry. Oh, okay. So it's because the way I arrange the layers. Okay. Right. Thanks so much. You helped solve this problem. Yep. So this is actually a very simple error, but then it will change how your plot appear. Okay, a very typical example in ggplot. Okay. Right. So now we got our okay, I'll just move this. Yeah, so this is what we want. Okay. To answer Peter's question. Okay. How you could move the plot title, okay, to the middle. Where was my plot? It's here. Okay. Yep, so we got it. Right, yay. Okay. Okay, and then there's one more question after Peter, which is sometimes the journals want species names in italic if it's a title. Okay, all right. I think you can also specify it in the plot title function. Yeah, I don't exactly remember this. Yeah, I usually Google it when I need it. Let's see. Okay, I think it's somewhere for plot title. So let's say if was it face? Let's try face. Italic. Okay, I was always confused with the team function because that is a lot of different options available. Like you have the axis and the plot. Let's see. Okay, so I got it right this time. Yep, so if you want to change your, I don't know if this is what you want. Is this what you're looking for? If you want to change the plot title in italic, this is how you can do this. If you want to change just a part of the plot title, so let's say you have 10 words in your title, and you just want to change maybe the second and the third words to italic. I don't think it's possible. You probably will have to edit your plot in let's say Illustrator or some plot editing software. I don't know if that's a way to like just edit some of the words, okay, in the title, okay, to a different font. Or if someone has other suggestions to edit just part of the title to a different font, but I will probably use an editor, okay, to do this. And yes, still. Did I pronounce your name incorrectly? Yes, still has a question. Is the plot configurable if you export it to Excel or PowerPoint? So what you're trying to ask is, can you edit the plot if you export it into your local folder? Is that your question? Okay, so it is configurable. That means if I want to edit my plot after I've saved it, I can still edit it. But you have to use like I said, an editor like Adobe Illustrator, or I think because I don't have the license with me anymore with Illustrator, okay, they have retracted the license. But a very nice alternative is to use Affinity. This one I've installed it, okay, in my computer. Okay. But I guess the best format, or the preferred format for if you want to configure your image in Illustrator or Affinity is to save it in PDF. Okay, because I don't think they accept all different like PNG format thing, but yeah, so the best format to save your plot is to save it in as PDF. Okay, which is probably I should mention how you could save your plot now, just to show you how you could edit it next time. Let's see. Okay, so I just jumped quickly to how you can save your plot into your local folder, okay, by using the gsave function. So we have looked at how you can export and save your data frame, okay, using the write CSV function at the very beginning of this of today's workshop, okay. But if you need to save a plot, okay, maybe from ggplot, okay, or a figure from R, usually we use the gsave function, okay. So exporting and saving plots, okay. All right, so let's say if I want to save this one. Let's see. Okay, let me save this. Okay, so in order to export your plot, you have to save your plot into an object first. So I'll just save it as my plot. Okay, simple name. Okay, so I'll save this into my plot. Okay, and I'll just look at my plot. Okay, and then I'll use ggSave to save my plot into my local folder. Okay, so if I go to files, okay, this is my current working directory. Okay, and I want to save it into the figure folder. Okay, so what I have to put into my ggSave function is first of all the name of my plot. Oops, haven't. Okay, so I'll name it as, okay, I'll give it the same name. Okay, my plot. Okay, let's see. So I'm going to save it in the subdirectory, the figure directory, and then the name will be my plot. Okay, so I'll save it in PDF, and then the next thing that I have to put in is the name of the object, okay, the plot object, which is my plot. Okay, and in ggSave you can customize the width as well as the height of your plot and also the resolution. Okay, so let's say width, I'll just give it a 15, and then the height 10. Okay, yeah, so using different width and height ratios will usually change the how I guess how zoom in it is, your plot. Okay, and then if you want to set the resolution of your plot, you can use this function. 300 is the default, yes. Okay, all right, so let me just check if I have something in my, okay, no, it's empty. Okay, so my figure folder is empty. Okay, and when I run this, so I'll just run this code, ggSave. Okay, so it's successfully run. And if I check my figure folder again, I should have my plot.pdf being saved in this folder. Okay, and if I go to my Finder window, should have the figure as well. Okay, so let's say if you want to edit this figure further, if you want to configure, let's say I want to make some of the words in my title in italic. Okay, I can do this in an editor. I think Affinity is free, is it? I'm not too sure. I think Affinity comes with Mac, like as a default. It comes with Mac, but I'm not sure for Windows. Okay, so yeah, this is something extra, but I'm just going to show you how you could actually do this in Affinity. Where's my Affinity? It's here, then it's not showing. Right, so this is how it looks like when you open it in Affinity. Okay, and so you can choose the different things that you want to configure. Okay, this is also something useful in R. Okay, if you make your plots in R, you can actually ungroup them and further configure them in an easy way. Okay, so because sometimes if you make it in a different like PowerPoint, you can't really edit it further. Okay, but in R you can edit most of the stuff, okay, that you want. So let's say if I want to change this, I want to remove the italic, I can remove it and I can italicize it. Okay, just one or two of the words. Okay. Yeah. Not promoting Affinity, but this is useful. Okay. All right. Yeah, so remember if you want to edit or further configure your plot, it's better to save it as PDF. Okay, I think SVG works as well. Okay, there is another open source editor available. I think it's called Vector. I couldn't remember the name. What was the name of the other editor? anyway. Yeah, there should be a free open source editor available if Affinity is paid. Okay, but yeah, if you need to configure your plots. Okay, so the last, or actually this should be the second last thing, is how you could, let's say if you have made two different plots and you want to arrange, or you want to combine these two plots into a single plot. Okay, I think someone posted an alternative image editor is the draw.io, okay, in the chat. Let me see. I should try to remember. What was the oh yeah, okay. So it's called Inkscape. Yeah, I remember it now. I think Inkscape is a pretty nice editor as well. It's free, you can download it and install it onto your local computer. Yeah, but I don't really like the features. I don't think it's that user-friendly. Okay, but it's a free option nonetheless. Okay, I'll just post the Inkscape link in the chat if you need it. Okay, right. So back to the RStudio. Okay, so what we are trying to do next is let's say if you want to combine two or more plots together into a single plot. Okay. An easy way to do this is by using the patchwork function, or the function from the patchwork package. Okay. So if you check under your packages, oh, I should delete these. Okay, under packages, try to look for patchwork. See if you have it installed in your R environment. Okay, so I have it pre-installed. Okay, but if you don't, you can install it. Okay. So what we are trying to do is plots using patchwork. Nope, patchwork. Okay, so if you do have patchwork pre-installed, you can install it using the same code, install packages, and then patchwork. Okay, so I'll just skip this run and go straight to loading the library. Patchwork. Okay, so it's loaded in my environment. Okay. So some simple rules in patchwork is depending on if you want to arrange your plots side by side or or in oh, sorry, did someone mention something? Yeah, so depending on if you want to arrange your plots side by side or on top of each other. Okay. In other words, if you want to arrange it horizontally or vertically, you have to use different symbols. Okay. So let's see. So we're going to make two different plots and then arrange them on top of each other. Okay, so let's try this. So the first plot that we're going to make is we are going to make a box plot. Okay, probably I should just copy and paste one of the box plot that I have. So where was my box plot? Box plot. Okay, I'll just take this one. I think this was the very first box plot that we have. Okay, let me just run and see what it gives. All right, so let's just take this box plot. Okay, and then the second plot, let's take a maybe I'll just take the the line plot. Okay, the time series plot that we have previously. Okay, how about this? Okay, and then I have to save this into an object. Let's save this. So let me just rename this as maybe plot 1. Okay, first plot. And then my second plot will be a line plot. Right. Okay. Second plot. And then I have to change this name as well. Right, so I'll just double check my first plot and second plot. Okay, so they're looking pretty good. Okay. Next thing is I want to arrange these plots. One on top and the other one at the bottom. Okay, so what I'll do is I have my first plot. Okay, and then I'll use the / okay, followed by my second plot. Oops, I think I forgot the underscore here. Okay, and I want to add something extra to set the height of my both of my plots. Okay, so I want let's see, probably I want my first plot to be slightly higher, slightly longer than my second plot. Okay, so to set the heights of my plots, I can use the plot layout. See, where's the plot layout? Okay, plot layout function. And inside the plot layout function, I'll put in the heights equals to a vector. Okay. So I want the ratio of my plot heights to be 3:2. Okay, which means my first plot will be 3 times and my second plot will be 2 times. Okay. So if I run this, okay, so this is what we get. You can see that the first plot is slightly longer or higher than the second plot. Okay, if we change this, let's say 2:2, it should give the same heights. Okay, where's my plot? Right, so this time, if the ratios are the same, I mean, I should put it as 1:1, but anyway, yeah. So if the ratios are the same, they should appear as the same height. Okay. So this is how you can use patchwork to arrange or combine 2 different plots together. Okay. So what if oops, that is a comment. Okay, so that's a comment in the chat. How do you increase the space between the x-axis for plot 1 and the title for plot 2? I'm not sure if that is an option. Does anyone have any idea where we can where we can increase the space between the x-axis, between the first plot and the second plot title? Yeah, okay, yeah. Sometimes the journal would ask for this. Yeah, worst case, I would just switch to the editor. Okay. I'm not sure if that is an option. Because it's a pretty tricky option here. You want to introduce more space between the first and the second plot. Yeah. You can try Googling or try Stack Overflow. Okay, but I doubt that you would get any useful information. Yeah, worst case scenario, you can try the image editor. Okay, if you really couldn't find anything useful. Okay, so So we have looked at how we can arrange the plots on top of each other. What if we change this to plus? Okay, so plus is a symbol used when you want to arrange the plot side by side. Okay, so let's see what this gives us this time. No, it's still the same. What if I remove this? All right, so I have to remove that one. Okay, because the plot layout is for the vertical plots. So if I use a plus symbol, okay, this will arrange my plots side by side. Okay, if I zoom in, this is how it looks like. Okay, there should be an option to set the width of the figures as well. I wonder if the width works. Let me just try something here. Width to, oh, okay. So yeah, so you can set the widths of your plots, okay, but not the heights, because the heights are for when you arrange it like top to bottom. Okay. So let me just add in a comment here. Combine plots vertically, and then the second one is to combine plots horizontally. Okay, so I guess that is pretty much all that we have to cover in for this part of the workshop, which is on ggplot. Before actually and before we actually summarize what we have learned so far, I just want to show you a very useful website to get the codes to make different R plots. Okay, so there is a website. Let's see. I think there are two very similar websites. Okay, they're kind of giving the same. Anyway, okay. So it's called R Graph Gallery. Okay. So if you go to this website here, I'll just copy and paste this in the chat. Okay, some of you might have been to or might have used this website before. Okay, so what it has is everything that you need. So it offers different kinds of plots. Okay, so let's say if you want to make a violin plot or a histogram, a box plot. Okay, let's say if I want to make a scatter plot. Okay, I'll just click into this, and it has many different customizations or many different types of scatter plots that depends on what you want to make. Okay, let's say if I want something like right, something like this. Okay, so if I click into this, it will give me the code that I need to make this plot. Okay, so it's these are the libraries that you have to load into your R Studio. Okay, so in this case, they're using ggplot and K3R team. So this is basically for you to use the color schemes that they use in the plot. Okay. Yeah, so this is the layout, okay, or the what do you call that? The template that you use to make that plot. Okay, and then there are other options as well. So this is a pretty useful website if you are looking for simple codes to make some customizable plots. Okay. And then they have maps option as well. Yeah, I find maps in R pretty complicated, I would say. Yeah, but it's something nice to have. Okay. Also when you're unsure of what kind of plots you want to make, this is, I think, the go-to website. Okay, just to look at the different options available. Okay, I'll just paste the link in the pad as well. Do I already have the link? No. But I think I do have this. Yeah, I think this is the. Yeah, so this is another website which offers, yeah, the different types of plots available in R. I think, yeah, it's pretty similar to the one from just now. Okay. I guess it's more organized in this. I'll just copy and paste this in the pad if you need it. Okay. So what's the time now? It should be 12:30. Okay, so we still have a bit of
Yep.
time. So right. So I'm just going to show something that I find useful. Oh, sorry. Okay, that I often use. In this case, I actually use it all the time. Okay, when I'm running my R script. So let's see. Okay, so what we have been doing so far is we are running our codes in simple R script. Okay, but there is another option to run your code in what we call a markdown file. Okay, so the difference between an R script and a markdown file, I hope you have not covered this in the previous workshop. Okay, about the R markdown. I think this is not part of the workshop, but something extra, okay, that I want to show you. So to make a R markdown file, okay, so this is how you, let's say if you want to make a new R script, this is what you go to. Okay. If you want to make a new R markdown file, okay, this is what you should choose. And then it will prompt you for a title. I'll just give a random R demo. Okay, and then it will open up a new R markdown file for you. Okay. The difference between R script, a basic R script, and a markdown file is that you write your codes in what we call code chunks. Okay, so this is a code chunk. Okay, and then this is another code chunk, and yeah, another code chunk. Okay, and then in between the codes, or in between the code chunks, this is where you can put in your comments. Okay, so usually we put in comments in the R script as followed by a hash, but in a markdown file, you don't need the hash to for your comments. Okay. What's nice about R markdown is that it allows you to visualize your plots right away or directly below your code chunk. Okay, so I'll just delete this stuff here. Anyway, I'll just add it below. Okay. So let's say if we are making a, let me just look for one of the plots that we have. We not have a decent plot. Just trying to look for, okay, so I'll just take this one. Let's take this. Okay, So what I'm going to do is, so this is the code that I want to run. Okay, and I'm going to put it in the code chunk. Okay, so to add a new code chunk, okay, what I have to do is I'll just go to this C icon over here, and then add in a new code chunk. Okay, and then I'll copy and paste this into the code chunk. Okay, so depending on which, you have different options for your code. So if you're running an R code, you can specify it as R in your code chunk. Okay, if you're running bash, let's say it in your terminal, you can change this into bash. Okay, but yeah, we're looking at R in this workshop. So yeah. Okay, so what's nice about R Markdown is that it allows you to visualize. Let's say if you want to visualize different versions of your plot, or different versions of your plot at each stage. Okay, so what I mean is, let's say if let's say I started making my plot as a scatter plot. Okay, so I'll just leave a comment. Okay, make a scatter plot of weight against species ID. Okay, and if I need a scatter plot, okay, I'll just remove this. Okay, so what I'm doing here is I'm commenting out this line so that it's not included in my final run. Okay, I'm making this line into a comment. Okay, so which means when I run this code, only this part will be run. Okay, so if I run this, okay, and if I run this, so I'm using the shortcut key to run this command, which is if you're using a Mac, it's Command plus Enter. Okay, so I run this, and if I look at my plot, so this time instead of printing it out in the right-hand panel, okay, in the plots panel, it actually prints out the plot directly below the code chunk. Okay, and then the next thing is I want to add the next layer, which is the germ box plot layer, into my current plot. Okay, so I'll add a comment, add box plot to current, and then I'll make a new code chunk. Okay, just copy this, paste it, and this time I'll add in the germ box plot function. Okay, I'll add in this layer. And when I run this, so I'll run this. Okay, you don't have to highlight it when you run, but I'll just highlight it to show you. Okay, so it shows me what happens to my plot when I add in a second layer. Okay, so the difference here is if you run it in a normal R script, it only shows you one plot at a time. But then if you run it in R Markdown, it actually shows you all of the plots that you generate in R, okay, simultaneously. Okay, so it allows you to see the difference between each plot, okay, which is a useful thing in R Markdown. Okay. Yeah. And the other thing for R Markdown is it allows you to knit it into HTML file, which is you can make, that means you can make all your codes into a HTML page. Okay, and you can save it as HTML and post it online. Okay, make it into a web page as well. Okay. Yep. So I think that's all that I want to show. Okay, R Markdown is pretty useful. Okay, if you're dealing with multiple plots or even other stuff. Okay, but if you're just a beginner, or it's pretty sufficient to have to run your code in just a basic R script. Good. All right, so I think that's all that I want to show. And that's pretty much all we have for the last part of this workshop. Yeah. So just a summary before we really end this workshop, or before I pass it to Angelique. Let's have a very quick recap of what we have tried to run today. Okay, so going back to the very first part, we have to look at how you can pivot or convert a data frame from wide to long format, or from long to wide format, and then how you could export and save your data. Okay, using the right CSV functions. Okay, and then we move on to the major part of the workshop today, which is using ggplot to make our first plot, okay, a scatter plot, and then how we could reduce overplotting using different ways, okay, by either changing the transparency of your data points or using germ jitter. Okay, I guess these are more useful when you have a smaller data set. Okay. And then we look at how you can customize the colors of your data points, tried a few exercises, and how you could, where was it? No, right. And how you could make a simple box plot, okay, or if you want to remove the outlier points from your box plot, or you can also add on a layer of scattered data points onto your box plot. Okay, or an alternative to box plot is to make a violin plot, which shows the actual distribution of the points. Okay. And then we look at how we can make time series plots to look at changes of a certain variable over time. Okay. And then how you could use a different syntax to pipe in your data frame into ggplot. Okay, and faceting, how you could split a single plot into multiple different plots, customizing themes, and titles. Okay. And lastly, how do you export and save plots into a local folder? Okay, and also how we could use patchwork to combine 2 or more plots together. Right. Good. So I guess that's pretty much all for ggplot. If you are looking for more functions or more, I would say more utilities, if you are curious about how you could make other different plots, you can always look up at I think we have a few Carpentry's tutorials or workshops available, okay, for more advanced R learning. Okay, so yeah, you can always look up to the other workshops offered. Okay, but yeah, I guess for this workshop, it's pretty much we covered everything. And yeah, so thanks everyone, and I guess I'll pass it back to Angelique for the closing and as well for the survey.
Thank you so much, Gia. I really appreciate it. And thank you. All the great questions from you in the room. I really enjoyed just digging deeper into visualization. I haven't done it in a long time. I do make maps now and again. I shared a blog post earlier this week with the group, Gia, of a map I made for a blog post. But thank you so much for sharing these 5 days with us and allowing us to showcase what you can do with R and OpenRefine as well as spreadsheets. Before we go, I would invite you to please complete the post-workshop survey. For us, it's for us, it is essential to see where we can improve, what we did well, did the curriculum meet your needs, etc., etc. So Tutkile said she'll be in the room at 12:30, but I'm not seeing her here. So I might hang around for another 5 minutes or so. I'm going to stop the recording right here. There we go. Well, one day I'll do it right.